Welcome, everyone. Today, we are taking a deep dive into what is basically a massive bottleneck for engineers.
Oh, yeah, a really huge one.
Right, because, well, traditional machining optimization methods, they often require these, numerous expensive physical experiments, and those just consume valuable machine time, material, and energy.
Yeah, it's just a massive drain on resources. But there is a groundbreaking solution we're looking at today. It's a system pronounced MEVO.
Okay, let's unpack this right away.
Yeah.
I mean, is MEVO like, say, using a smart scout to map a dark room instead of just walking in and bumping into the furniture?
That's a perfect analogy because instead of stumbling around, MEVO starts with just a minimal data set of initial experiment.
Wait, minimal, like barely any data.
Exactly, just a tiny starting point. And from there, it trains a machine learning model that acts as a digital twin of the machining process.
Oh, I see. So it builds a virtual copy to test on so you aren't wasting real material.
Spot on. And then it adopts a smart search strategy. This is based on meta-heuristic optimization, long-term memory, and evolutionary operators.
Hang on, I need to push back on that last part. Evolutionary operators, because when I hear the word evolution, I instantly think of like survival of the fittest. Does the system just discard the weak data as it goes?
No, that's a really vital distinction. It is not about survival of the fittest at all.
It's not.
No, the evolutionary operators are applied to the best solutions found so far to, propose new trials. But all the previously generated trials are kept in the dataset.
Oh, okay. So it intentionally remembers the bad moves so it never repeats them.
Yes, the model never loses its historical knowledge. And as new experimental results are added, MEVO continuously updates its model.
That's always learning.
Right. It's learning and accelerating toward the optimal solution without having to start over.
That makes perfect sense, but I mean, a digital twin is only as good as its real-world application. What happened when they actually tested this on an aluminum alloy?
The results were pretty wild, honestly. MEVO achieved a 52 to 57% reduction in experimental effort.
Wait, 52 to 57%. That is, you're cutting the physical trial and error in half.
Easily. It entirely outperformed the traditional industry standard, which is the response surface methodology.
Wow.
And here's the best part. It yielded simultaneous improvement in both energy and surface roughness.
Okay, I have to jump in because usually there's a hard trade-off there, right? Like if you want a smoother surface, you have to run the machine longer, which obviously burns more energy. How did it improve both?
That is the power of that smart search strategy we talked about. Older methods get stuck on those conflicting variables, but MEVO's digital twin can simulate so many micro adjustments that it focuses on the most promising regions of the design space.
So it just finds that completely hidden sweet spot.
Exactly. It finds solutions that older models just can't see.
That is incredible. But thinking about you, the listener, why does this matter if you aren't, standing in front of a milling machine every day?
Because MEVO's broader potential is massive. I mean, it's about finding better solutions with fewer physical trials in so many different industries.
Like what kind of industries?
Think about any scenario constrained by strict experimental budgets. So, production line optimization, complex material and product design, or even laboratory experimentation.
Wow. So it fundamentally changes how we test things when testing is expensive.
Yeah, absolutely.
It really makes you wonder, though, if minimal data digital twins can optimize current machines so perfectly, could they soon invent entirely new, hyper-efficient manufacturing techniques we haven't even conceived of yet? Thank you for listening.